All right, so this is what we're going to cover today. We're going to cover the slopes, distances, midpoints, equations of lines, and equations of circles. That'll pretty much cover 4 sections out of the chapter. And then the last 2 sections we'll do next time, and that deal with absolute values and inequalities. All right, let's begin. A point. A point is a location, a coordinate. On a graph. In mathematics, the first thing we were introduced to was the number line. We started off with what are called whole numbers. Three is from 0 on to infinity, increasing 1 each step, and it goes all the way to infinity. And then we learned about negative numbers. If we go the other direction, we have negative numbers. All the way to negative infinity. We call that the number line. All right, so how does that relate to what we're doing now with points? It's points of location. So the location of that point is at 2. And that's okay. But now we introduced another direction. We first used to go horizontally. The way humans traveled, we first used to go horizontally. And then eventually we learned to fly and then go in submarines. So we started going up and down, which is now where we needed to have a vertical axis in our graphs. The center is called the origin. That's where everything begins. From that point, going to the right are all the positive numbers, all the way to positive infinity. To the left are the negative numbers, all the way to negative infinity. Then from the origin going up, it's the positive numbers, all the way to positive infinity. And going down are the negative numbers, all the way down to negative infinity. So it all starts from the center and either go up, down, left, or right. These 4 parts are called quadrants. This is our first quadrant. This is our second quadrant, our third quadrant, and our fourth quadrant. They're named that way because when math and equations were first being developed, the only number system they had was the sundial. And the sun started in the east and went all the way to the west and then back around. So that's become the numeric, the quadrant system goes counterclockwise to us. All right. In each quadrant, you have locations. These are called the points. Another name for them is ordered pair. A point is an ordered pair. Ordered pair of what? Well, we have to know horizontally where we're going, and we have to know vertically where we're going. So that's we have to label them first. The horizontal axis we called X, and the vertical axis we called Y. Every point, every ordered pair is in that configuration. You have an X and a Y component. It all starts from the origin. The origin, its ordered pair is 0, 0. And you start from there. So to get to this point, from here, we go 1 to the right. That's positive 1. And then we go up 2. So we go 1 on the X, 2 on the Y. And there's our point. And we can do that to any quadrant. So this point here in the second quadrant, you start from the origin, you go to the left 4, so it's negative 4, and then up 1, so it's negative 4, 1. That point there. You start from the origin, you go to the left 2, so it's negative 2, and then you go down 4, so it's negative 4. And the point in the fourth quadrant, start from the origin, go left and right first, so horizontally first, so it's 3 to the right, and then down 2. So you see that in any ordered pair, the numbers can be positive or negative, or 0. If it's positive, it goes to the right. If it's negative, it goes to the left. In the Y component, if it's positive, it goes up. If it's negative, it goes down. Yeah, it all starts from the origin. All right. Now you notice also that in each of these 4 quadrants, in quadrant 1, both of the values are positive. Because yeah, start from the origin, you go to the right and up, so it's positive, positive. In the second quadrant, it's negative, positive, because you have to go to the left and then up. In the third quadrant, both values are negative, so you have to go left, then down. And in the fourth quadrant, it's positive and negative. So just by looking at any numbers, the signs of any numbers, you can tell me which quadrant they're in. The 0.53, it goes to the right, then down, so we're in quadrant 4. We go right, then down, so it puts us from this one, go right, then down, we're in quadrant 4. They're both negative, so from the origin, you go to the left, then down, that puts us in quadrant 3. So again, the signs of the numbers helps us determine what the location of our number is. So that's one benefit of that. Right. So the question next would be, what do we do with points? Well, if we have a point, we can't do too much with it. Because if I gave you a graph and a point, can you tell me the equation of a line? Can you tell me the slope? Can you tell me? No, because through that one point, I can draw an infinite number of different lines through that point. So some singular point only tells us the location of where we're at. If we have 2 points, Then you can find the slope of the line connecting those 2 points. You could find the distance between those 2 points. You could find the midpoint, the location halfway between those 2 points. And you can also find the equation of the line connecting the points. So you see, we need to have 2 points in order for us to be able to do anything. Okay, so let's look at that. Let's start off looking at 2 points and see how we find everything. Let's say we have a point there. And we have a point there. If we have, the moment we have 2 points, I can connect them with a line. I could find the location halfway, the midpoint, halfway between there. I can tell you the slope, the gradient between this point to that point. And I can find the equation of the line. So first thing we have to discuss the distance between 2 numbers, not points, but numbers. In other words, how far is it between 2 and 7? How far is it? How many numbers are there between 2 and 7? It's 5. How about between 12 and 93? It's 81. So this is number 1, and this is my second number. The distance between number 1 and number 2 is like that. $135 and $410. The distance between there is 375. So the distance between my first number and my second number, I don't care what that, any x1, x2 you give me, is simply going to be the second number minus the first number. 7 minus 2 is 5. 93 minus 12 is 81. 410 minus 135. 410 minus 135. 93 minus 12. 7 minus 2. So the distance between any 2 numbers, between any 2 points, is just that. Take the second and minus the first. And I just use that. It would also do it with the y values. So if we're going up and down, the first one and the second, so it's going to be the second number minus the first number. So that's the distance between two numbers. Second number minus the first number. So the distance between 1 and 5. 5 minus 1. The distance is 4 units. The distance between 1 and 4 is 3 units. So again, that's my first number, that's my second. So the distance is x2 minus x1. I use x because x is the horizontal axis. And I use y in the vertical because y is the vertical axis. So the distance vertically is y2 minus y1. So that's the first thing we have to understand. How to find, if I give you two sets of numbers, we have to look at the difference between the x components and the y components to be able to go any further with this. Once we understand this part, the rest of these, to find the slope, distance, midpoint, and equations is just a process of plug and play. So the hardest part here is you have to first be able to tell me what x1, x2, y1, y2 are. Why is it just simple plug and play? Because they are formulas. Where you plug in the correct numbers and work it out. Two weeks ago, I discussed, that, remember, mathematics is a language. It's a philosophy of logic, which means a language is made up of words. The sooner you memorize the words and their definitions, the easier math becomes. That's a promise. Notice I put definitions in quotes. Because a definition in math is not simply a verbal one. It also is defined defined by a formula. So when I say know the word and its definition, you have to know what the formula is to be able to go any further. Okay, let's begin with our list of definitions. Slope. When I say slope, what does it mean? What am I talking about when I talk about slope? The formal definition, it's the gradient from one location to another, or to a second. Yeah, that's a boring one. We have a better one. What does gradient mean? It simply means, if like for roofs, if you have a house, your roof has a certain slope. So from this point to this point, there's a certain change. It changes vertically and it changes horizontally. That's called a gradient. But again, these are all formal words. Slope by definition is rise over run. So slope is simply rise over run. It's the vertical change over the horizontal change. And whenever we talk about change, yeah, it's another word you know. Change is defined by the second value minus the first, or y2 minus y1. Change is simply the subtraction between one point and another point, another number and another number, which is what we called distance earlier. If you think about it, if you look on a map, if here's Dallas and here's Fort Worth, the distance is simply the change of how far it is from Dallas to Fort Worth. That's the change. So distance and change are synonymous. So let's look at this. Vertical change. Vertical deals with the y values. So the y values, the change of the y values is y2 minus y1. The horizontal values are the x's. That's x2 minus x1. That is your slope. That's your slope. Yes. You have a question?
No, Professor, all good.
Okay. Now, instead of writing the word slope all the time, in mathematics, we use the small m to represent slope. And there's your first formula. The formula for a slope. Like I said earlier, once you understand, okay, the slope, whenever you say slope, you know that that's represented by the letter m. it's represented by the formula y2 minus y1, the second vertical minus the first vertical over the horizontal ones. So let's refer back to our picture. Let's refer back to our picture. Right? So I gave you 2 points. One, this would, the location is 1 for that one. And the location for this one is 5, 4. So I gave you 2 points. Which one is the first point? Well, if you took your pen or pencil like this at the when x is 0 and move it to the right, the first point you get to, we'll call that point 1. Point P sub 1 means point 1, the first point. You keep on going, we get to the next point, we'll call that one point 2. The subscripts represent what point you're looking at. So the first point is represented by x sub 1, y sub 1. Remember, the 1 represents which point we're talking about, with the x component of the first point and the y component of the first one. P sub 2 is represented by x sub 2, y sub 2. So the x component of the second point, the y component of the second point. So the P1 is 1, 1, and P2 is 5, 4. And now I'm going to keep on going through a bunch of steps. So your first step, what you want to do is label x1, x2, y1, and y2. Whenever I give you an equation, a question, I give you 2 points or any points, label them, point 1, point 2. And then from there, you can tell me what x1, x2. So in our example, x sub 1 is the x component of the first point, which is 1. X sub 2 is the x component of the second point. Second point, the x component is 5. Y sub 1 is the y value of the first point, which is 1. And y sub 2 is the y value of the second point, which is 4. Once you label x1, x2, y1, y2, the hard part's done. So the second step is determine what formula you need to use So in this case, since I'm asking you to find the slope, I'm asking you to find the slope. So the formula for the slope is y2 minus y1, x2 minus x1. We know we have everything labeled. We have the formula. I'll plug in the values. And solve. So y2, what's y2? It's 4. y1, it's 1. x2 is 5. And x1 is 1. We plugged in the values of x1, x2, y1, y2. Now we solve it. 4 minus 1 is 3. 5 minus 1 is 4. And there you're done. Leave the slope as a fraction. Don't put it in a decimal form because decimal forms mean nothing to us when it comes to the graphs. So how would you interpret this? If I gave you m equals 3/4, what does that mean? Rise of one. Yes, that's it. That's literally what it means. But what does it mean? Yes, it tells us. It gives us the directions from one point to the next. The slope tells us the relationship between our points. Let's look what this means. Our slope is m, is 3/4. 3 is the vertical change. 4 is the horizontal change. It's the vertical change and horizontal change from the first point to the second. So from this point, from 1, 1, the vertical, if we go up 3 spaces, 1, 2, 3, and then to the right, 4 spaces, 1, 2, 3, 4, we'll get to the next point. And that's the slope. That's what the slope means. It tells us the ratio, the relationship from the first point, P1, to the second point, P2. And then from the second point, P2, to the third point, P3, and P4, and P5, and P6, forever. So that's what the slope tells us. Once you define the slope for a line, it's that way forever. For a straight line. Okay, so that's slope. How about the distance between the 2 points? Distance is a length. if we look what's happening here between point 1 and point 2, we have a horizontal change. We have a vertical change. Now, this creates a right triangle. Do we know any formulas for right triangles? Very good, the Pythagorean theorem. The Pythagorean theorem says that if you have a right triangle and the sides, the shorter sides A and B and the longer side C, it's A squared plus B squared equals C squared. It works for any right triangle where A, B, and C are the lengths of the sides of the triangle. Lengths. There's the optimal word there. Now, since let's label these we call vertices, these points. The way we do it in mathematics, since this is the length A, it corresponds to that point there, the opposite side. Since this is length B, it corresponds to that side, B. And this side C, so it corresponds, so that's my value C. That's how you label points in a geometric figure. It's always the vertex opposite the side. Now, again, I said earlier, the length. Have we discussed lengths before? Length equals distance. If you could throw a rock 100 yards, all that means is if you're standing here and you throw the rock 100 yards, that length is 100 yards. It's the distance from where you are when the rock lands. So length and distance are the same thing. Let's go one step further. So here you are throwing a rock, and here's where the rock lands. This is horizontally, so this is x1, x2. Do we know how to calculate the difference between those two? X2 minus x1. So the length of a side, the distance between 2 points is simply the second point minus the first point, horizontally and vertically. So here we are, we're back to that same formula. It's the same parts. Now what we have to do is we have to combine this x2 minus x1 stuff with the Pythagorean theorem. Let's combine those two. Right? Here's how we do it. We have a triangle. This is C, that's A, that's B, A, lengths A, B, and C. And we're using the formula A squared plus B squared equals C squared. So how would we represent A? What is A represented by? It's the horizontal length, right? And have we used any equation for the horizontal length? Like in slope? Perfect. X2 minus X1. Because it's the horizontal axis, it's X2 minus X1. Since B is the vertical axis, it's Y2 minus Y1. And so A is simply the distance between C and B. B is the distance between A and C. And this side here, C is simply the distance between A and B. Now let's put it all together. So A is X2 minus X1 squared. B is Y2 minus Y1 squared. And C is simply the distance between those points. It's the distance squared. C has a name. It's called the hypotenuse. The hypotenuse is simply the distance from A to C, or A to B. So far so good? Because yeah, the distance between B and C is A. X2 minus X2 minus X1 is simply the distance between B and C. Y2 minus Y1 is A and distance between A and C. But now, since we have some kind of a slope thing going on, we have to take both the vertical and horizontal, which is that's why we have X1, X2, Y1, Y2. So there's your formula. There's your formula for the distance between point 1 and point 2. How do we know it's the distance between 2 points? Because look at what is X1, what does X2 represent? Point 1 is made up of X1, Y1. Point 2 is made up of X2, Y2. So since we have X1, X2, Y, so we have 2 points. That's pretty cool. Now, how hard is this? Well, not hard at all, because remember I told you earlier, once I give you a graph, the first thing you want to do is label the pieces. So we've labeled X1 equals 1, X2 equals 1, Y1 equals, no, X2 equals 5, I'm sorry. Y1 equals 1, Y2 equals 4. Remember, we had 2 points. We had 1, 1, and we had 5, 4. That's point 1 and point 2. So just plug these values into the equation. So the distance between point 1 and point 2 is given by that equation. So X2 is 5. X1 is 1, bless you. Y2 is 4. Y1 is 1. 5 minus 1 is 4. 4 minus 1 is 3. Have we seen these numbers already before? In the slope. Top part is y2 minus y1, x2, 3 over 4. That's what it is. The y values is 3, the x value is 4. So once you do the slope, you have the values for the distance. Just square them and add them together. Four squared is 4 times 4 is 16. 3 squared is 3 times 3 is 9. 16 plus 9 is 25. Have we found the distance yet? No. Distance is d. We have to get rid of the square, the 2. So the way we get rid of that is we square root both sides. Later on in this course, we're going to learn why this is, but square roots and squares cancel each other out. So the distance, square root of 25 is 5. So the distance between point A and point B is 5 units. So now we know the slope, we know the distance, we keep on going from there. How about the midpoint between point 1 and point 2? The midpoint is just that. It's the location. It's a location. It's an X and Y location of the point halfway between point 1 and point 2. Now, all the clues you need are right there. It's a location halfway. So now, first off, the symbol we use for midpoint is the capital M. It's a location. So therefore, the midpoint is an actual point. So we have to know. So if we're looking at our graph, we want to know what this thing is halfway through. So since it's a point, we have 2 halfways to look at. What is the point halfway between these 2? And what is the point halfway between these 2? How do we find that? Oh, no, you're so close. It's not x2 minus x1, because think of it this way. Let's say there's your test grades. Let's say you made an 80 on the first test and 100 on the second test. So what the midpoint, the halfway, is an average. How do you find the average of 2 grades? Add them together and divide by 2. Yeah, you were close. You were almost on spot with that divide by 2. Yes. So what we have to do here is we have to take these 2 values, the beginning and the end, add them together and divide by 2. So this midpoint is at 3. Likewise here, 4 plus 1 divided by 2 is 5 divided by 2 is 2.5. So it's x1 plus x2 divided by 2, y1 plus y2 divided by 2. There's your formula for the midpoint. It's the average location of the horizontal and vertical values. Again, back to what I said earlier, once we label the x1, y1, x2, y2, once we label those, it's just a matter of plug and play. x1 plus x2, so it's 1 plus 5 divided by 2. And then 1 plus 4 divided by 2. 5 plus 1 is 6 divided by 2. 1 plus 4 is 5 divided by 2. So the midpoint, 6 divided by 2 is 3. 5 divided by 2 is 2.5. It's an improper fraction. 2 goes into 5 twice with 1 left over. So there's your actual location of the point halfway between point 1 and point 2. So far, so good. Let me ask you some questions here. If I gave you, now we'll do it in a little bit. So the next thing I'm going to talk about is before we go to equations of lines, I want to look at equations of circles. I want to look at equations of circles because of the formula we're using already. First off, what is a circle? A circle is an infinite number of points that are all equidistant from a central point. What does that mean? Let's look at this. We have a graph. Then for this one, I'm going to use the center as 0, 0. So if I have a point here, we know that that distance is d. But it also, since it is a point, I can create it into right triangles. Likewise, if I had a point there, it can be created into right triangles. That one also. So each one of these points, I can create right triangles, but they're all the same distance away from the center. If I keep on going, eventually all these points will get so close that I have a circle. That's all it means. So that A circle is created by a whole bunch of triangles. These points, each of these points on the circle, all create a right triangle. So that's pretty cool. I thought it was cool. So the equation of a circle. Is that. Have we seen that formula before? Yes, that's the Pythagorean theorem. That defines the distances of right triangles. So we're using right triangles to define something that's circular, which I think is always pretty cool. Now, what do we call the distance from the center to the circle itself? What do we call that? What's that distance called?
A radius.
Very good. The radius. It's the radius. And points A and B, that's x2 minus x1 squared, y2 minus y1 squared. So there we have our formula for a circle. With one small change. We have a fixed point in the middle. That center point. The center point, we're going to call it HK. Does it ever move? No, it always stays where it is. So that's our first point. HK is the same thing as our x1, y1. It's our first point. So in our formula, instead of having x1 and y1, I'm now going to use h and k because those points are fixed and stationary. The center never moves. These points on the circle, yeah, they change because if x is 0 here, it's that one y value. If that's 0 is y, has an x, so the x and y values change. The only thing that never changes is the distance. So there is our actual formula for our circle. The radius is the distance. HK represents the center point, and x2, y2 are any x and y values you can give me. It has to fit one unique spot on the circle. So let's look at examples here. Find the equation of a circle with radius 4 and center at 5, 7. So what do we know? We know R equals 4. We know H and K are 5 and 7 respectively. So we just plug and play. R is 4. Leave X and Y alone. H is 5. And K is 7. And there's your equation of a circle. Let's look at another one. EOC with radius 1 and center at -3, 0. Go ahead and work. Give me the equation of the circle. Since we're doing equation of circles, we put r squared equals x minus h squared, y minus k squared. Well, we know the radius r is 1, h is -3, and k is 0. Because remember, the center is at h, k. So those values automatically. 1 squared, x minus -3 squared, y minus 0 squared. Negative and negative becomes a positive. Y minus 0 is, so there's your equation. Yeah, it's plug and play. One thing I want you to be sure to be able to see. Notice here in this first one, notice inside the parentheses, it's x minus 5, y minus k, x minus 5, y minus 7. Inside the parentheses, whatever those things are, the answer is always the opposite. Since h and k is a center, if it's x minus 5, that means it's positive 5. Y minus 7, it's positive 7. X plus 3, that means h is -3. And since there's no y plus or minus anything, that means k is 0. Because now I'm gonna give you an equation. I want you to work backwards and tell me the parts. Find R, H, and K. But I want to know the center and the radius of this equation. Let me, while I was working on that, all right. So remember, since we're dealing with equations of circles, the formula is this. Since that's squared, that means the radius r is 6. Since there's no parentheses, h has to be what? 0. Since there's no plus or minus. Y So it's -2 here, so the answer is +2. There's your center and there's your radius. There. Find R and C, the radius and the center, of 7 equals x plus 3 squared plus y minus 1 squared. Remember our equation. What's our center? Opposite that is -3 and +1. And the radius? Let's see, because look what we have here. Okay, in this previous one, r squared equals 6 squared, right? They're both squared, so r has to equal 6. This one, r squared equals 7. There's no squared. So I have to get, I'm trying to find r, so I have to get rid of the square. I have to square root both sides. So r equals square root of 7. So that's why whenever you solve these things, make sure you write down the formula so you know what you're looking for. How would you graph a circle? How would you graph that circle? First thing to do is find r and c, the radius and the center. So in our case, we have r squared equals x minus h squared, y minus k squared. So our radius is, since they're both squared, r is 3. The radius is 3. Remember, always take the opposites. That's a -2. The answer is +2. That's a +1. So the answer is -1. Well, let's just finish this. I'm going to ask about why that is. Why it's always the opposite, what's inside there. Now, once you found R and C, plot the C point. The C is at 2, -1. From the center point, go up, down, right, and left R units. Since that's the center, the radius is 3. So from here, I go up 3. 1, 2, 3. I put a dot. I go to the right 3. 1, 2, 3. I go down 3. 1, 2, 3. Go left 3. 1, 2, 3. Connect the dots. Draw your circle. And there you have it. So once you have an equation, find the radius in the center, plot the center, and from there go up, down, left, right, the R units, the radius units, and connect them, make them a circle. That's how you graph a circle. You can always work backwards. If I give you a graph, you can tell me all the other information. Given a graph, find R and C. That was more so. I'll give you this picture. You can tell me what the center is. What's the center? Yeah. 3, 1. So it's at 3, 1. Can you tell me the radius? Well, from the center, it's touching this point here. How far is that? Yeah, so the radius is 3. That's all there is to it. Once you have got, find a point that's either left, right, up and down, that's solid and you can get to. Just count them and it tells you the radius. Now, the question I was gonna ask you is, if I gave you this, what's going to be the radius and the center? What's the radius? 3, because it's under the square. What's the center? 4, -5. Yeah, because it's opposite these signs. Now, the question I have is, why is it the opposite of the sign that's inside there? Yes. Yes. Okay. Yeah, you're right. That's one way you can look at it. X minus h squared, y minus k squared. Here's x, check. That's a minus, so h has to be 4. Here's y. It's supposed to be minus, but the only way a minus can be minus is if k is a -5. Yeah, that's one way you can look at it, but here's another way. All circles start off from the origin, right? So now what happens from there is they could move. It moves from 0, 0 let's say this point is 3, 4. So where does this, the center of the original equation starts at 0, 0. It had to do what? It had to move to the right 3 spaces and then up 4 spaces. So that's this is our new equation. So how do we get it from here back down to here? Like this example. What would this equation look like if the radius was 3? What would this equation look like? X minus 0 squared, y minus 0 squared, because that's the origin. So it's 3 squared equals x squared, y squared. So this is, we want to, basically what we do is find out, what does it take to get back to 0, 0? So if we take these two equations here, x minus 4, and set it equal to 0, I want it to be 0, and y plus 5, set that equal to 0. Solve for x and y. So x equals 4. Y equals -5. So my h and k are 4, -5. So that's what's happening. But that's the why we're doing it. Anyway, that's okay. So we talked about midpoint, slopes, distance formulas, equations of circles. We're almost done for the day. Wow, actually, we didn't do a lot so far. Here. Graph the line going through 2, 0 with slope -2/3. I know we haven't talked about graphing lines, but we did talk about how to graph lines. What does it mean? So the first thing you have to do is what? Plot the point. Since we know the first point is at 2, 0, it's right there. From that point, follow the slope to the next point. So remember, a slope is the vertical change over the horizontal change. Rise over run. Whenever you have fractions, the negative always belongs to the top number, especially in slopes, because in slopes and graphs and equations, the x value always goes to the right. The x value always goes to the right. So the top number is either going to go up if it's positive, down if it's negative. So from this point, we go down how many spaces? How many spaces? We go down 2. Because it's -2, and then over 3. 1, 2, 3. Plot the next point. Draw the line. Once you have 2 dots, you can draw a line. There's your graph. So plot the point that's given. From that point, follow the slope to the next point. When you get to the next point, put a dot there and draw the line. So before we move on to equations of lines, there are 4 slopes that are possible. Remember, slope, the equation of a slope is y2 minus y1, x2 minus x1. These are our 4 possibilities. These are our graphs. If your slope is positive, the graph will look something like this. If your slope is positive, greater than 0. If your slope is less than 0, if your slope is less than 0, your graph looks like this. I don't care about the position of it. It's the direction the line is pointing that's important. If the slope equals 0, the graph looks like this. And if your slope is undefined, the graph looks like this. Those are the only four possibilities. Okay. Now let's look at what this means. Let's look at these 2 points. What this one says is 0.1 is lower than 0.2. This is 0.1, this is 0.2. Likewise, if 0.1 is higher than 0.2. If 0.1 equals 0.2. We'll go a little bit further there in a second. Not 0.1 equals 0.2. I can't say that. I can't really say that because you notice that the x's are different. Here, the y values are the same. The y value of 0.1 is equal to the y value of 0.2. And likewise here, if the x value of 0.1 is equal to the x value of 0.2. Those are the four. Remember I said earlier, when you have a graph, so go to the first point, move your pen to the next point. Is the line going up or down? Up, so it's positive slope. If from first point to the second point, the line's going down, so it's negative slope. From the first point to the second, the line's not moving, so it's no slope, zero slope. If there is no second, you can't go anywhere, it's undefined. Let's look at what it means. Again, it's the y that's important. You notice in this equation here, x1 and x2 are different, right? So this will never be 0. So this will never equal 0. But if both of the y values are the same, what happens here? If y1 equals y2, then y1 minus y1 is equal to 0 over some value of x. If the 0 is on top, the answer is 0. Because y2 equals y1, that means they're the same number, then you get 0 over x. And likewise here, if the x values are the same, then you get y over 0. Anytime you divide by 0, it's undefined. So if the 0's on top, and there's a number on the bottom, the answer is 0. If there's a 0 on the bottom and a number on top, then it's undefined. Very important. Now, why is this? Why is 0 on top of 0? So how many times does 2 go into 0? 0, no times. But how many times can nothing go into 2? Infinite. That's why it's undefined. I can give you nothing infinitely and never run out of stuff to give you. So far, so good. All right. I need to show you this because the next part of finding equations of lines, we have to deal with slopes first, in which we did that already. Let's look at finding equations of lines. Finding equations of lines. Now, when I say equations of lines, there are 3 forms of lines. There's the first form. This form, when you see it this way, it's called the point slope form. Can you guess why it's called a point slope form? Okay, it has the m, has a slope. What's x1, y1? x1, y1 is a point. Right, so it has a slope value and has a specific point. So that's the first type. The second, y equals mx plus b. This one has another name. We know what m is. M is a slope. But the b is the intercept. It's more so the y-intercept. The value for b is the y-intercept, which we'll talk about intercepts in a second. The y-intercept is where the line crosses the y-axis. The y-intercept is where the line crosses the y-axis. The location of it is 0b. So whenever you see a value for this one, whatever that number is there, that's your b value. That's the point of intersection of the y-axis. The third form is called the standard form. Notice in the standard form, x and y are on the same side. A and B and C are numbers. Positive, negatives, or is it even zeros? The only stipulation is A has to be positive. That's the only stipulation. A has to be positive. All right. Now, all of these came from the same place. All three forms started with the slope formula. So let's look at this. First off, slope. We have y2 minus y1, x2 minus x1 equals m. And I'm going to stress this a lot during this course. Whenever you have fractions and an equal sign, we want to get rid of the fractions. So let's get rid of the denominator. The way you get rid of the denominator is by multiplying both sides by the denominator. So we multiply x2 minus x1 to both sides. So you notice in the slope, we have x1, x2, y1, y2. Because in order to find the slope, we have to have 2 points. We have to have 2 points to find the slope. But to find equations of a line, we only need 1 point. I'll show you what we're going to do with that. So here we get rid of the x2 minus x1 cancels. So we have y2 minus y1, m x2 minus x1. Okay, we don't want 2 points here because we would have to find the equation of a line. The equation of a line has to have an x and y value. So this is the reason we get rid of x2, y2. Which gives us our equation of the line in point slope form. So the point slope form, you need a point, 1 point, and you need the slope. So if you're given a point and a slope, just plug them in there and you're done. Let's look at an example here. I'm going as fast as I can. Let's look at this example. Find the equation of a line in point slope form. Given the slope is 5 and it goes through 3, 7. By it, I mean the line. So we're given a point, 3, 7, and we're given a slope. We're given a point and a slope. So logically, we would use the point slope formula. Because unless the question says use a specific format, just use what you're given. If I just gave you this, said find the equation of a line, and I didn't tell you in point slope form, you can just plug in the values and you're finished. So what is y1? 7. What's m? 5. And x1? There you have it. There's your equation in point slope form. You don't have to go any further. It just asks for the equation in point slope form and you gave it to me. Okay, let's go to the next step. Starting from here, since we're given a point and a slope, find the slope intercept form. Remember I said earlier, math is a language. What does the slope intercept form look like? Very good. So basically all it's telling us is solve for y. That's all it's telling us is solve for y. So before we do anything, get rid of the parentheses, distribute. Positive times positive is positive. 5 times x is 5x. Positive times negative is negative. 5 times 3 is 15. Next step. Add 7 to both sides. 7 minus 7. So we should have y equals 5x. 15 is bigger than 7. 15 is negative, so the answer is negative. 15 minus 7 is 8. And there we have it. Y equals mx plus b. So let's look at these things. What's your slope? And your y-intercept? Very good. It is -8, but the way you answer it in the computer, because remember the y-intercept is a point, it's a location. So it's 0, -8. That's the location of your y-intercept. So far, so good. The third form, now we went from slope, point slope, slope intercept. Now find the standard form. So we start with y equals 5x minus 8. What does the standard form look like? Ax plus b, y equals c. So in other words, x and y have to be on the same side. So we have to get rid of the 5x. How do you get rid of the 5x? Since it's a positive 5x, we subtract 5x from both sides. Not like terms, so we have negative 5x. Y is positive. Those cancel, equals negative 8. And remember, the coefficient, the number in front of the x, has to be positive. So at this stage, all you have to do, change all signs on both sides. So change that to a positive, change that to a negative, change that to a positive. So the answer becomes 5x minus y equals 8. And there's your answer in standard form. Pretty good. So that's how you convert from one form to another form. It's just understanding what you're looking for and solving for that variable. To find the equation of a line, you need a point and a slope, M. Find the equation of the line in slope intercept form. Find the equation of the line in slope intercept form. Going through 2, 3 with slope negative 5. Okay, we want slope intercept form. Slope intercept form is y equals mx plus b. So how do you start? Well, you have the slope, you have a point. So can you just plug it in here? Okay. The answer is yes, but I'll show you what, not just yet. Since we're given a point and a slope, let's start off with the point slope formula. It tells you what formula is easiest to start off with. So we plug in our values. Y1 is 3. M is negative 5. X minus X1 is 2. This is X1, Y1. Label those. Now solve for Y. Since you want it in Y equals mx plus b. We have to first get rid of the parentheses. Negative times positive is negative. 5 times x is 5x. Negative times negative is positive. 5 times 2 is 10. Get the y by itself, we have to add 3 to both sides. They're both positive. 10 plus 3 is 13. And here are the steps. Plug the info into the point slope form. Solve for y. You were absolutely correct the first time you said we can use this formula. Here's a shortcut. Plug in the values you have into y equals mx plus b. So remember, we had a point x, y that was given to us as 2, 3. And the slope was -5. So what's y? M is -5. X is 2. Because the only thing we're missing is the b value. So let's find the b value. Solve for b. So we have negative times positive is negative. 5 times 2 is 10. Add 10 to both sides. B equals 13. We know b equals 13. We know m equals -5 already from the beginning. So plug m and b into y equals mx plus b, and you're done. You can use either method. The shortcut is faster in this case because you already have x, y, and m. Just solve for b and plug it back in there. So far, so good. Let's see here. It goes through the point -5, 3. With slope 1/4. Now we have fractions. Find the equation of the line in slope intercept form. So that's it. We want the equation y equals mx plus b. Plug in x, y, and m. Solve for b. Plug m and b into y equals mx plus b, and you're done. Okay, so it's asking for the equation of the line in slope intercept form of the line going through the point -5, 3 has a slope 1/4. So what is y? Yeah, this is x and y. M is 1/4. X is -5 plus b. All right. So whenever you have fractions and equal sign, do this. Step 1. Find the LCD, the least common denominator. What is the LCD in this case? It's the only denominator we have, 4. Because before we actually do that, can anything cancel here? No. So since nothing can cancel, we can multiply straight across. So negative times positive is negative. 5 times 1 is 5. 4 times 1 is 4. We can combine them. So once we found the LCD is 4, multiply the LCD to each term. A term is anything separated by plus, minus, or equals. So step 2 says multiply the LCD to each term. What all that says is, all that means is put everything in your equation inside parentheses and just put a 4 in front of it. So put each of these terms inside parentheses and just put a 4 in front of each term. That's all I did there. Step 3. Reduce. Because the whole purpose is to get rid of the fractions. 4 goes into 4 once, 4 goes into 4 once. Notice these are the same equations. It's just that the bottom one looks easier to work with. Multiply to remove the parentheses. And solve for B. So I have to get rid of the parentheses here. I reduced, got rid of the every fraction, so there's no more fractions. Then I multiplied to remove the parentheses. Positive is positive is positive. 4 times 3 is 12. Positive times negative is negative. 1 times 5 is 5. Positive is positive. 4 times B is 4B. And solve for B. Add 5 to both sides. They're both positive, so 12 plus 5 is 17. Divide both sides by 4. So B is equal to 17 over 4. And we know the slope is already 1/4, so we have all that stuff. Just plug them into y equals mx plus b now. M is 1/4 x. And b is positive, so nothing changes there, 17 over 4. And there's your equation. What do you think? A lot of, I'll think about moving on further, but that's a lot of stuff we've done so far. Because there's only one more thing left I could show you all is parallel and perpendicular lines. But I'll do that next time. We'll do that next time. So we're done for the day. So please, please, please start doing your work so I could, because we're getting close to a marking period. We'll have to just send you a updated grade of what you're doing so far, or how you're doing so far. So any questions, anybody in TV land?
Oh, good, Professor. I just have one question.
Yes.
I wanted to know where I could find the link for today's video
I'm gonna
online.
actually, that's what I've been working on all week, because downloading these things, the school network has been acting up, and I finally got everything downloaded last night about 2 o'clock in the morning, and I have everything set up. I just have to put them in online on eCampus. I'm gonna put it on eCampus, and I'm also gonna send it to you all via Remind.
Very good. Thank you so
I'll do
much.
that. I'll do that this afternoon. Good question. Thank you. Okay, everybody. I'll see y'all next week. Be safe. Be good. Take care.